Okay, guys, if you needed help on the last page, the last set of problems, when dealing with angles with the quadrilateral, you had to kind of remember that all quadrilaterals, I'm just going to say quads, have a sum of 360. I know that because of 4 sides minus 2 times 180, n minus 2 times 180, or 4 minus 2 times 180. If I double 180, that gives me 360. So if I'm dealing with angle relationship with just the vertices, just the angles in each shape, then I'm going to use my sum of 360. So they want us to find the missing angles here. So what I did was dealing with the kite, or what you could do is go back to the summary sheet and focus on just the angles in the kite. So when I'm looking at the angles of the kite, they have a single arc here. Then there is a double arc on each of these two. And then there's 3 arcs here. So I'm just going to duplicate that relationship. So if I look at the problem I have here, I don't have any diagonals. See, in this summary sheet, we have diagonals drawn. So I'm just going to look at the angles, and I'm going to start with that single arc. That would have happened at E and T. Those 2 angles are congruent. If I wasn't too sure, I would look at angles or read the properties about angles. This is talking about sides, perpendicular. One pair of angles are congruent, exactly one pair. And it says one pair of angles are bisected. So the pairs across from each other here are the pairs that are congruent. This is showing the bisecting part. So I don't have a diagonal in this example, so I'm just doing the one pair opposite are congruent. So to find that missing angle measure, you're going to add up the angles that you do know, which are 29 and 95. That gives me 124. We know that the total sum of a quadrilateral, any quadrilateral, is 360. So I'm going to do 360 minus that 124. But then since I know these 2 angles are congruent, I'm going to divide that answer by 2. So this came out to be 118. So on the B, remember only one pair of angles, exactly one pair, are congruent, and that would be T and E. So that lets me know that E is also a measure of 88. So to find my missing angle S, I'm going to add up the 3 angles that I have, which is 107, 88, and 88. And then take that sum and then subtract 360 from it. And I ran out of room, but you should have got 77 here. Okay. Now, for 27 A and B, now we're dealing with the diagonal. So I went and looked at the actual diagonal segments. So we have this real long one right here, has no markings on it. Then we have the short one here, no markings, but we do have the box and we do have tick marks on the side. So what I kind of started off on the partial key was showing those diagonals, looking at the markings and the measures. We had 3 and 3 here, so that was important. Let's see if that's better. Maybe, I don't know. If I do this, maybe that's better. It's not showing. But anyway, sorry. Keep showing that eraser when I'm about to write. Well, anyway, so they want us to find the length of each side. So what I did was I went ahead and said, well, these 2 sides are not the same. One has 1 tick mark, 2 tick marks. These are. So I'm just going to label that side Y, or actually let me make that one X, and this one Y. Okay, and then I'm going to focus on this right triangle that's on the interior right there. So even if I just kind of move this to the side here, hopefully you see this right angle. We have legs 3 and 7. We're trying to find that missing hypotenuse. So if I plug that into the Pythagorean theorem, that would have been 3 squared plus 7 squared equals my x squared. 9 plus 49 equals x squared, which really is going to be 58 equals x squared. And then we're taking, oops, wrong color, sorry, taking the square root of that. So my x was approximately 7.6. So then I'm just going to repeat that skill to find the longer side, the y. So hopefully you see the right triangle inside of here. My legs are now 3 squared plus 10 squared equals my y squared. That's 9 and 100. Don't let this confuse you, sorry. 9 plus 100 equals the y squared. So 109 equals y squared. But then take that square root. So y is approximately 10.4. So we're doing the same thing on this kite here. So they went ahead, showed the 6 and the 6. So I know those are the same. But then just got to remember that those diagonals are perpendicular. To find each side length, remember only one set of consecutive, or two sets of consecutive sides are congruent. So tick mark, 2 tick marks, right? Just like on the marking on the summary sheet. I'm gonna make this one X, this one Y. Start off with the triangle here to the left, which would be our legs 11 squared plus 6 squared equals my x squared. Do your Pythagorean theorem. 121, 36 equals x squared. Basically, I'm taking the square root of these two sums. So x is approximately 12.5. And then we're going to do the same thing for the y. So this would be 6 squared plus 14 squared equals y squared. And then we got to use that leg here. So 36 plus 196 equals y squared. Then we're going to take the square root of that sum. So y was approximately 15.2. Okay. So you might have to use Pythagorean theorem to find your missing sides, or to find your missing diagonal if you have the sides. Now on 28, we had an isosceles trapezoid. I know it says trapezoid, but it's actually isosceles because we have these tick marks right here. And you had to remember the property that was needed for this was that the base angles are congruent. So if I have 53 on A, then B is also 53 because you have a base at the bottom and you have a base at the top. Now to get my missing angle 127, I showed it right here on the partial Greek key. You just do 180 minus 53 because the left side, that side is a pair of consecutive angles that are supplementary. So if you're now applying that relationship to B, the first thing I would do is do 97 with angle D, because that is the base. Remember, your base angles, or your bases, are the parallel sides. So the arrows are going left and right here, up and down versus horizontal. So this is a base, and then my B and my C are the other base angles. To get to my C, you're not going to have to do 180 minus that 97, which gives us 83. Okay. And then for this last section here, it says tell whether the statement is always, sometimes, or never true. It says a trapezoid is a parallelogram. That is never. A trapezoid can never be a parallelogram because a trapezoid only has one pair of opposite sides right here, parallel, where a parallelogram has two pair. Okay. The bases of a trapezoid are parallel. That is always. It's part of its property, its relationship, its definition. The base angles of an isosceles triangles are congruent. That is always. It says the legs of a trapezoid are congruent. That is sometimes. When it's an isosceles, yes. When it's not, no. Okay. And then you had a challenge problem, and I'm just kind of going to get you started with this. I'm hoping maybe if you color code, you can see the relationships a little bit better. So I'm going to highlight A, B, F, E. That is the rhombus. Okay. I'll probably make that a little bit too dark, but if this is my rhombus, then a rhombus is a parallelogram with all four sides congruent. So I'm going to add these tick marks to know that all of those sides in that yellow rhombus is going to be congruent. And then they tell us that you have a rectangle E, B, C, D right there, okay? So then I'm going to start, for it to be a rectangle, it has to have a right angle, right? And in a rectangle, the diagonals are perpendicular, are congruent and bisect each other. So this is a diagonal right here in the rectangle EC, and BD is a diagonal in the rectangle. And I already have a tick mark to show it's bisected. And in a rectangle, all of these parts to the diagonal have the same marking, and they're all congruent. So hopefully I'll get you on the right track here. Now, also, what we're going to do is start off with labeling what we have. EC, that is that whole diagonal, is 10, which lets me know that each of these parts here is going to be 5. So everywhere I see a tick mark, it's going to be 5, guys. And that'll hopefully help you get on the right track. Then it says ED is 6. Now that's part of my blue rectangle. In a rectangle, opposite sides are congruent. And then it also tells us that EF, which is this diagonal in the rhombus, is 6. Now, the diagonals in the rhombus, if you need to go back and see that on the summary sheet, are perpendicular. There's a box, and they do also bisect. So if I go back to my problem, I'm going to put a box here. That whole thing is 6. The diagonals get bisected, so that lets me know it's going to be 3 and 3. And then to get to the perimeter, you're going to need to know this missing side here, DC, to get our distance around. And in order to do that, I have to remember in a rectangle, opposite sides are congruent. So I need to basically, this is what I'm going to show you where to go. You need this missing part, because it's going to be the same as that missing part. So hopefully you can see another shape inside of that rhombus to help you get to that shape, to that side. That's as far as I can take you. Hopefully you see the right triangles. That might help you as well. All right, guys. Please use your flashcards that were posted on Teams, and make sure you've studied this review. Come prepared. I know you have a formula chart, but you got to know your shapes to help you get through it and not have to waste time reading on the problem. All right.